I heard you counting down. I heard that countdown from 10. Hey, first off, thanks to Mike Olbinski for letting me use his video. Mike is a remarkable weather photographer. His videos are just stunning. If you like that video, go to his YouTube page or his Vimeo page. Mike Olbinski, Olbinski. He's out in Arizona, and he does a great job. But it's Thursday morning. Here we are. We're going to do this every Thursday morning at 10 o'clock Central, 11 o'clock Eastern, while we're in the midst of this situation across the country where school is out. And again, for those that don't know, my name is James Spann. I am a meteorologist, and I would typically be in a school at this hour of the day doing a school weather program. I love to teach science. I would be, if I didn't do this for a living, a third grade science teacher. So thanks to all the parents and you kids for watching. Hope you've had a really good week. And by the way, notice I'm at the beach today. I thought, let's just get away. Let's get away. Let's go down to the beach. I mean, there's nobody down there. It's nice and quiet. And that's actually not true. You see, I have a green wall in my home office. In fact, I'm actually doing the evening television weather broadcast from this home studio for a while. We're trying to spread out as best we can in our news department. And so I'm just going to be here for a while. But the cool thing is, when you've got this green wall, you can be just about anywhere you want to be. So I thought I'd pick the beach today. Next week, you never know. So what have you guys been doing? I thought about trying to grow some hair. This is what I would look like. This is an artist simulation. Actually, it's a Snapchat filter. But that's not really a good look, so I don't think I'm going to do that. So today we're going to do Ask Spann. Yes, you kids have submitted hundreds of questions, and I can't answer them all today. We'll try and blend these in as I do these Thursday morning segments, but I thought we'd just do an Ask Spann today. We're going to open the floor and let you ask some questions. So, ladies and gentlemen, let's get right to it.
Spann, what makes the weather?
Now, that is the $64 million question. What makes the weather? Well, first off, if we didn't have any weather, I wouldn't have a job. I am very thankful that we have weather. So here's the deal. The Earth is an amazing place. We have an amazing home. In fact, this satellite image was captured within the past 30 minutes. That's what we look like right now. Everybody watching this, if you're on this side of the planet, you're in that photograph. But understand the Earth is surrounded by a blanket of gases, which we know as the Earth's atmosphere. And it's held near the surface of the planet by the gravitational attraction of the Earth. And without that atmosphere, there would be no life. It's good. The atmosphere contains the air we breathe. It protects life from harmful rays coming from the sun. It helps keep the planet warm from the sun by helping the heat escaping back into space. And of course, it is a major element of the water cycle. So that's where the weather happens in part of the atmosphere, not the top part. In fact, the atmosphere has layers. The top part is called the exosphere. The lowest part, the one near the Earth, the troposphere. And that's where the weather happens. And the deal is the Earth is spinning. We're constantly rotating. We're tilted on an axis, 23.5 degrees. We're orbiting the sun. And all of this movement means that the air moves, the atmosphere moves. And the motion of that air makes the weather. And again, I'm so thankful we have weather because that's what I love. Next.
What instruments do meteorologists use to check the weather?
Ooh, that's a great question. Weather instruments are very important to us. In fact, let me show you what an instrument shelter looks like. This is how you really need to measure the weather properly for certain instruments. This is an instrument shelter. And within that, which, by the way, is about 6 feet off the ground over grass, you have a thermometer. And it's important to have a thermometer in that shelter because in the summer it gets hot. And oftentimes thermometers don't do a good job, especially car thermometers, the ones on bank signs, the one that you might even have in your backyard. You want it to be in a shelter so the sun's rays are not directly on that. Air flows through that. Notice you've got the side and the back ventilation. But there's a thermometer in there. We also have a barometer, which measures the weight of the air over us. We have a hygrometer that measures moisture, water vapor. And then we also have an anemometer that measures wind speed, wind direction. In fact, this is one of our weather instrument stations. We have a number of these all across my state here. And we have a camera there, too. We like to be able to see the weather. That's important. Radar can't show us the weather right at the ground level. So we have a camera. The anemometer's up there at the top. The little black bucket, you know what that is? That is a rain gauge. It measures how much rain that falls. And down below the little black bucket, those white circles, that is a radiation shield, much like that shelter that I showed you that keeps the direct rays of the sun off of that. But inside there, we have our thermometer and the hygrometer, and we take all that data and we make maps. And like we talked about last week, I just love maps. And of course, we also have weather balloons. You saw this last week. Every morning and every evening, balloons are launched all over the United States, all over the world, and it sends the data back to us about what's happening, not at the surface, but way up to the top. And those balloons pop about 100,000 feet off the ground. So those are weather instruments. But I will say this, in looking at all the questions, we've had a common subject matter, and it's the word that starts with a T, and it's the wind that goes around and around. Everybody likes tornadoes, or it seems like it. So let's get some tornado questions. What do you say?
Hi, I'm Addie from North Fork. How do tornadoes happen?
James Spann, how are tornadoes formed?
Spann, why do tornadoes come?
Hey, Emily, do tornadoes knock down houses?
These are great questions. Here's a few more. This is from Robert. Robert is 8. He wants to know why tornadoes happen. And by the way, he wants to be a meteorologist when he grows up. And he's proud of his tools. Robert, grow up in a hurry, buddy. We need all the help we can get. And this is from Colton. He's 9, and he wants to know how tornadoes form. And the note says that he went through a tornado a couple of years ago in March of 2018. And for those that have experienced a tornado, you can become anxious and worried, and you can become fearful. And that's not true only of kids, but also of adults. But let me just say this. There's one good thing about a tornado. There is one very good thing. You ready? They don't happen a lot. Hey, nobody watching this, and I mean nobody, saw a tornado outside this morning. You know why? We didn't have one. Nobody saw a tornado yesterday. You know why? We didn't have one. Nobody saw one Tuesday. Do you know why? Yeah, we didn't have one. Listen, you might grow as old as me. And listen, Mr. James is old as dirt, okay? And you will never, ever, ever see one. Never, ever, ever be afraid of tornadoes. They don't happen a lot. It takes a very odd set of circumstances, so never be afraid of them. And storms are good. We need the rain. We talked about that last week. But let's talk about what you have to have a tornado, okay? So first off, you have to have a storm. And again, I love this time-lapse animation. This is a summer storm on a hot afternoon, bubbling up. You can't have a tornado with no storm. If it's clear where you live today, there's not going to be a tornado. And most storms don't produce tornadoes, even where storms develop. Most of them are not severe. They're helpful. We need the rain. But the deal is, on the way up, that updraft, you need to have a change of wind from the surface up to the top of the storm. And that change of wind direction can set those big updrafts into motion. And also, sometimes we have rotation down on the ground that's taken up in the cloud. In fact, there is a professor at the University of Wisconsin that made a fascinating 3D rendering of a large tornado that formed. Take some time to watch this, and you'll get a pretty good idea. That is awesome. That is an amazing animation. Again, that's from our friends up at the University of Wisconsin. And they have a program up there called the Cooperative Institute for Meteorological Satellite Studies, CIMSS. I was in Madison, Wisconsin several years ago at a weather convention from the National Weather Association, made many friends there, and they do just an amazing job. But that's a simulation of an actual EF5 tornado that happened in 2011. And by watching that over and over, you really start to get an idea of how it all comes together. Another thing I want to point out about tornadoes, there's a lot we don't know. Let me just say that one more time. There is a lot we don't know. As I get older, I realize that. The one thing you learn in this science as you get older is how much we don't know. There's a lot of things about tornado formation we don't know. But there's been some great studies, and I'm so thankful for the researchers. I'm a practitioner. The researchers are tremendous. For years, there's been a project called Vortex where they study tornadoes and how they form. Initially, Vortex was focused in the southern plains, places like Oklahoma and Kansas. But in recent years, a newer project called Vortex Southeast focuses on tornadoes in Dixie Alley, states like Alabama, Mississippi, Georgia, and Tennessee. Here's a little video to show more about Vortex Southeast and the great work they're doing.
What makes a tornado outbreak in the middle of the United States different from one in the southeastern states? That's what scientists participating in the third year of the field experiment known as Vortex Southeast want to know. The crew is focused on studying the unusual weather conditions in this part of the country.
You know, in general, a tornado is a tornado. But what's really different in the southeast U.S. is the kind of storms that form the tornadoes and the processes that happen in those storms. So we've looked at the supercell storms in the plains for 30 years, and we have a pretty good idea of how those tornadoes form. But if you look at storms in the southeast, they aren't supercells. They're completely different. The tornadoes form very quickly and very unexpectedly, and often from clusters or lines of storms instead of isolated storms.
2018 will bring opportunities for researchers to look at storms from multiple angles, including from NOAA's P3 Hurricane Hunter aircraft.
This year in Vortex Southeast, we're going to have a radar on the ground. We'll have 2 mobile Doppler radars near that radar. We'll have an airborne Doppler radar flying back and forth. And each of those radars looks at the storm from a different angle. And when you piece together that information from the various angles, you can come up with a 3-dimensional wind flow through the whole storm and find out how it's causing tornadoes.
What the researchers learn and combining it with data they've collected the past 2 years will help improve forecasts in this area of the country where tornadoes can be difficult to detect and as a result, more deadly. For more on Vortex Southeast, check us out online and follow us on Facebook and Twitter.
And we are so thankful for Eric and his team and understand the work is still going on here in 2020. And the data that's being collected will be taken by the researchers. They'll look at all of that and help us do better when it comes to tornado watches and warnings. Had one question about houses and tornadoes. And yes, tornadoes can cause damage to a house, but a lot of it depends on how the house is constructed. If a house is not built very well, it could be taken off the slab in a heartbeat, for example, if there are no anchor bolts. But the good news, most homes are very well built. And here's what happens. The first thing that happens, the roof tends to go away in a really big tornado. But notice how the lower floor is fine. This is why we go to the lowest floor. You don't have to be underground, just the first floor. And if your house has one floor, you're fine. And in that first floor, we want you to be in a small room, a hall, a closet, or a bathroom. If you are in those kind of places, you will be as snug as a bug in a rug. Never be afraid of these tornadoes. This video is coming from the Institute for Business and Home Safety. I met with their CEO, Roy Wright, earlier this year. Fascinating work that they do. They put these homes in wind tunnels that simulate tornado damage, and the damage all depends on the ranking. For example, this is what happens when an EF0 comes by. That's the weakest tornado. You'll get some damage to the roof. Some shingles will come off, but a good, well-built home typically is going to be fine. Now, for an EF1, sometimes a garage door can be blown in, and that might be the weak link in the chain. Winds like to work on that weak spot, and it kind of goes from there. We like to have reinforced garage doors. That's pretty important, especially for people that live around hurricanes down on the Gulf Coast. But as we go up to EF2, you can see that the damage becomes more severe. And, of course, obviously, once you wind up as an EF5, it gets really, really rough. All right, so here's another tornado question here. This is from Hunter. And let me just say, Hunter's got a good-looking outfit there. I don't know why I like that so much. That is a very impressive outfit. But the question is, how fast are the winds from an F5 tornado? And it's now EF5. We have the enhanced Fujita scale. And also, how long do you have to go to school to be a meteorologist like you? First off, let me answer the school question. If you want to do what we do for a living, you'll need to study meteorology. That's the science of weather, or atmospheric science. And not all colleges offer that. Some do, but many don't. So if you're an older student in middle school or high school, you might want to start looking around for colleges that offer that, because that's what you major in. You don't major in radio or television or journalism. You major in the science part of it. You'll pick all that other stuff later. And most people go to school for 4 years, but some keep going. Some have a master's, some have a PhD in meteorology. So, and again, there's just a whole lot to learn. Now, concerning the question about winds in an EF5 tornado, that's nasty. And that's our scale, by the way. The weakest tornado is an EF0. EF stands for Enhanced Fujita. I actually met Dr. Fujita one time. He was a famous tornado researcher years ago, and his initial scale was just called the F scale, F0. But a few years ago, we made some adjustments based on engineering and knowledge we have now, so it's the Enhanced Fujita scale. But to answer your question, 201 miles per hour or greater in an EF5 tornado. That's pretty rough stuff. All right, this is a question from Colson. He is 5 years old, and he wants to know, how can you see storms and tornadoes in the sky? And I love the note from the parent. When it stormed the other day, he said he was staying inside so he would not get the Bonehead Award. And let me just say, Colson, you're brilliant. Nobody wants to earn this award. We typically hand this out to these boneheads who stay outside during a thunderstorm, which is extremely dangerous. It's not that hard. This is not rocket science. When there's a thunderstorm outside, you go inside, even if it's not raining. You don't want to be the winner of a Bonehead Award from Mr. James. But here's the deal. How do we see storms? Well, first off, we have these big birds up in the sky. These are weather satellites, and these are about 23,000 miles over the Earth's equator, and they are constantly taking images of the planet, about once every 60 seconds or so. So we can see the tops of the clouds from the weather satellites, and down below that, we have this. This is called radar, and that lets us see what's in a storm. And we have maps with colors that look like this, and we can tell right away sometimes what's happening. Now, I showed this last week. Let's see if you remember. I'm hoping everybody watching remembers. There is a tornado in that storm. There is a pretty dangerous tornado in that storm. Do you remember where it is? Everybody think for a minute. Pick out your spot. Come on. Yeah, you got it. You got it. It's right there. And there was no rain right there, really. No heavy rain. That was the radar beam bouncing off debris in the tornado being lofted, picked up from the ground. So that's what radar and satellite will do for us. We don't have to be outside during a storm. They take care of it.
How does rain make hail?
Oh, we got a lot of questions like that about hail. So let's go to another one here. This is from Lily. Pretty much the same thing. How do the clouds turn water into ice to make hail? Well, here's the deal. In a big storm that's producing hail, and this one is, notice the little balls of ice out there in that grass. Those storms are typically 30, 40, 50,000 feet tall. And way up in that storm, temperatures are below freezing. The higher you go, the colder it gets. Notice the little dashed line in that chart. That's the freeze line. And so with that strong updraft, you get water droplets taken up into the layer where it's way below freezing. And water turns into ice. And if the updraft is strong enough, that ice can stay up there to get multiple layers, and finally it gets heavy and it comes back down. But the larger the hail, the stronger the updraft. And the stronger the updraft, typically the more dangerous the storm. So if you ever see really big hail like that, that means the storm can be fairly dangerous. So we got to watch those carefully. But remember, most storms don't produce any hail. All right, this is from Asher, 9 years of age, wants to know if acid rain is real and what it is. And I'm so thankful that people stop to ask questions like that. A lot of times you hear things or see things, and maybe they're really not true or they don't exist. But yes, the question about acid rain is very valid. It's real. Thankfully, within our country and most of the adjacent countries, they've worked very hard, these big industries, to reduce the pollutants that they let go into the atmosphere, but it's still a problem in spots. In some industries, the emissions coming from these big plants are acidic, and that can be taken aloft and ultimately translated into acidic raindrops. And when the rain falls, it can damage trees and plants. And understand, acid rain is not only the product of some big industries, but natural things like volcanoes. Sometimes during a big volcanic eruption, you can have the same type process, and acid rain will fall downwind from a big volcano.
Texas, and I'd like to know how earthquakes occur.
Ooh, it's an earthquake question. Let me say this. I am a meteorologist, and guess what that means? My expertise, it is in the Earth's atmosphere, things that happen above the Earth's surface. So when you're asking about earthquakes, that is a question about geology. And that's not really what I studied. I know a little bit about it, but my expertise is in the atmosphere. But here's the bottom line. We have a series of plates. The theory is called plate tectonics. That's kind of a big word, but when you have some time, just search that out and you can learn more about it online. But the Earth has a series of plates, and these plates are moving. Now, not quickly. They're just creeping along. But where the plates merge, you see those red lines? You often have a whole lot of fault lines around that. Notice one of those red lines comes down through California in the western part of the United States. That's the edge of the Pacific plate, and there's a lot of earthquakes there because of that. But when the plates kind of start to bump into each other, one might be nudged up or down, and you could have a pretty violent earthquake. We had a really big one in some of the islands of Russia just a couple of days ago.
Hello, my name is Silas, and I want to know what elements lightning is made of.
Well, Silas is rocking that Super Mario outfit. That's awesome. So elements in lightning. You know what lightning is? It's basically a bunch of electrons coming from water molecules. That's all that is. Electrons from water molecules that have been going up and down and up and down. And lightning is kind of a big deal. In fact, I've seen a lot of questions today on lightning. But what you see there, what happens within a big storm, you get the updraft and the downdraft. And you've got ice pellets, snowflakes, water droplets, some in the updraft, some in the downdraft. And near the middle of the storm, they constantly collide. And those electrons can become displaced, and after a while, you get a buildup of electrical charges, and soon you'll have a discharge of electricity that looks just like this. So lightning is something that happens in every storm. And like we talked about last week, the one thing you do is listen for thunder. Thunder happens because the air within the flash is heated instantly in 1 second to about 50,000 degrees Fahrenheit. When the air gets that hot in 1 second, it basically expands so rapidly it explodes. So when you hear thunder, that's when you get in. But back to the question, lightning, it's just a bunch of electrons.
Mom said, when it's lightning and thundering, I can't take a shower. Is that true?
Ooh, that's a good question. Now, if your mom said that, let me just say this about moms. Moms know everything. They're good. So the question is, let's say there's a thunderstorm outside and you want to take a bath or a shower. Is it perfectly safe to go in there? No. Your mom was right. It's not perfectly safe. Now, let me just say this. Most of the time, you take a shower during a thunderstorm, you're not going to be bothered. But if your house takes a direct hit from a lightning strike, then water can be carried by some of the plumbing into the bathroom in that place where you're actually taking a shower or a bath. So our advice is to wait if you can. That's what I would do. I don't take a shower during a storm. In fact, Ron Holly, who worked for NOAA for a long time, is an expert in terms of lightning injuries, and he estimates that 10 to 20 people in the United States are shocked every year while bathing, using faucets, or handling appliances during storms. So if it was up to me, I would probably wait until the storm passes. All right, this is from Sonia Kate. She's 8 years old. She wants to know, is there any such thing as a snow tornado? The answer is no. The conditions needed for a tornado within a storm are never there when it's that cold, when it's cold enough for snow. However, we can have thunder and lightning during snow. That's called thunder snow, convective snow. It doesn't happen a lot. I've basically heard it one time in my life, And this was in 1993 during a horrible blizzard that affected parts of the eastern and southern United States. But you can have thunder and lightning, but tornadoes during snow, no. All right, let's go to the next question. This is from Addison and Bryant. They want to know the highest tsunami wave on record. This is hard to believe, but it's true. How about 1,720 feet? Wow. That's brutal. I would not want to be in the path of that tsunami. This happened actually in parts of Alaska way back in 1958. And that loosened 40 million cubic yards of rock high above the northeastern shore of that bay. And that's the biggest tsunami that's on record. Goodness gracious, that is not good. All right. Got a few more here, and don't want to keep you too long today. This is from Lily in Lexington, Massachusetts. Go Red Sox. She wants to know how sinkholes form. They have one now in their backyard, and they think that it might be weather-related. Well, sinkholes are all about what? Water. Not necessarily water that falls. They can be, but also groundwater. It's pretty complicated, but the bottom line is any change in groundwater levels, flash flooding, anything that changes the water system in place around your neighborhood, that's typically what causes sinkholes. So maybe you've had a lot of rain, maybe the groundwater has changed and you've not had a lot of rain, but they can happen under certain circumstances. All right, so an adult snuck in here. The question is, when do you find time to eat, and what do you eat during long-form severe weather coverage? So where we are at my local television station, we can be on the air for 10, 15, 20 hours in a row, nonstop, with me standing on a green wall. Now, I'm sitting today. I can stand up if I have to. But the question is, what do you eat? The answer is nothing. Yeah, I'm not good at that. You know, some people can eat while they talk. I can't do that. Man, there'd be stuff flying all over the studio. I'd be sucking something down my throat. But here, I just grabbed some of the snacks we have back in here. I'm addicted to carrots. These little things here, you know, these baby carrots. I mean, I can suck these things down all day long. But I do have some things that are illegal, not on the approved list. We have poppables. We have Raisinets, chocolate-covered raisins, and the famous zebra cakes. But again, those are illegal, and if the guy at the gym where I work out sees this, I'm in big trouble for even saying this. All right, let's do one more. One more for this week. This is from Addison. Age 11 wants to know why we use a barometer. And Charlie wants to know why snow is so cold and why clouds are so soft. If I could pick one weather instrument, one to use, just one, if I had my choice of one, it would be a barometer. A barometer measures the weight of the air. Now, you don't feel it. I mean, look, right now, you're not thinking, man, this air is so heavy, I just can't move here. But we measure the column of the air over us with a barometer. When the barometer is falling, the air gets lighter and lighter and lighter, and that makes it easier for the air to go where? Up. And when air goes up, you get condensation, clouds, and rain. But if the barometer is rising, that means the air is getting heavier and heavier, and air tends to go where? Down. And when air sinks, the fancy science word is subsidence, then the weather is nice and sunny. So that's the deal. I would love barometers, all right? And let's review this other question real quick. This is from Charlie. Why snow is so cold? Well, it's pretty easy because about 5,000 feet off the ground, it's got to be freezing. You can't have snow if it's above freezing 5,000 feet off the ground. And even down at the ground, even if it's in the 40s, you've got to have cold air. It would melt otherwise. It would totally melt. So it's got to be cold. And clouds, why are they soft? You know, I've never really touched a cloud. Clouds are simply suspended water droplets. That's all they are, little tiny water droplets, and they're just suspended. Here's the deal. So if you want to see what a cloud feels like, do this. Next time there's a foggy morning, I want you to do this. This is your homework. Walk outside and just hang out for a few minutes. Come on, there's no school. You got time to do this. On a foggy morning, walk outside and just hang out and enjoy it because you are in a cloud. A fog bank is simply a cloud sitting on the ground, and that will let you know what a cloud feels like if you want to know. All right, we got to wrap this thing up because I have so much going on here. I thought with me working from home, I wouldn't have too many problems with time, but it's awfully busy. Real quick, if you want to get in touch with me, I'm on the Twitter, the Facebag, the Gram, all that stuff. That's my Twitter handle, and on the Instagram, it's SpannWX. And if you'd like to get in touch with me there or ask questions, I try and answer all of them as best I can. So that's it. Thank you guys for watching. Again, we're going to do this every Thursday morning at 10 o'clock Central, 11 o'clock Eastern, until you get back in school. Then I'll be back in school, and I can't do this anymore. And again, if you want to see last week's session, if you missed it, go to YouTube. I'll be posting this on YouTube. And you can just search James Spann Online Weather School, and you can see that from last week, and I'll post it over there as well. So I got to get to work. Thank you guys for watching today. Y'all have a great day, great week, and God bless.